So, Wendy, please come to the stage and give your presentation. Thank you.
Thanks, Thomas. Oh. So it's the intention of Thrive, together with the Centre for Safe Air and maybe some other partners, to produce in 2025 a State of Indoor Air report for Australia. So this session I'll step through the proposed structure and content, in essence to make sure that the report will have the critical elements needed to bring about change in regulations and in practice, keeping in mind TED's expressed views on the reports, and we want to make sure that what we produce is not just a report by scientists for scientists. Having said that, I will also say that I am not an air quality scientist. My academic background is in classical music, and it's also and my PhD is in buildings and sustainability. So my academic, my research is socio-technical, looking at buildings, what happens in them, what people want to do in them, and how all of those things are regulated. So I'm I guess a building scientist, socialist in that sense. And so what I'm presenting today is my thought processes on how such a report might be useful. And I have deliberately put in some things that some of you might think are provocative, and that is deliberate. So I frequently hear that Australians collectively and individually, that Australians spend 90% of about 90% of their time indoors. But what does that really mean? And how does that help us determine what the problem with indoor air quality is or what the solutions might be? So the Australian Bureau of Statistics, the ABS, have a periodic time use survey. So this, what I'm presenting today is from the 2020-21 survey. So the ABS says that your time is divided into 4 types of time. First of all, there's the time that you spent doing activities related to your personal survival. So that's eating, sleeping, personal hygiene. Then there's time that you are contracted to do things, either at work or it may be at an education facility. So this is paid work or a university enrolment, for example, where you have an explicit contract regarding that work about when you need to be at work and the activities that are to be performed. Then there's committed time, which is the time that you've committed to either your household or social or community interaction. So that can be a whole range of things. Housework, household management, maintenance stuff, child health care, shopping, volunteering, even your commuting to and from work, for example, is committed time. And free time is what's left. So that's how the ABS has determined is the categories of time that they use for this survey. And interestingly, so this is from the 2021 report, how women spend time and how men spend their time are slightly different in terms of, particularly in terms of contracted, committed and free time. And that's something that we need to perhaps consider. But why is that important? Where do these activities take place? So my question to you now is, why do we need to know where people spend their time indoors? Does anybody have any thoughts on it? It's important because different indoor environments pose different risks, because they, depending on what particular pollutants, outdoor and indoor pollutants, might be in those spaces. They have different types of building structures. They have different types of activities being undertaken. They have different occupant densities, and they have different demographics of the people doing those activities. So we can't just say we're going to solve the indoor air quality problem by just saying, well, 90% of our time is spent indoors. Which indoor environments are we spending time in, doing what activities, and perhaps the solutions may be something different. So that's the first premise of the report that we're preparing, is that we need to understand more about where and when we spend our time indoors. The second premise relates to what is an indoor environment. And I think we would all agree that it really relates to both buildings and transport. Actually inside cars, inside buses, trains, etc. So my next question is, should the report that we're proposing to do for next year include buildings and transport environments? At this stage, the team I've been working with have only been focusing on buildings because we probably spend a lot more time in buildings than in transport, except perhaps for me, for example, I commute from the bottom end of the Gold Coast, so I spend 4 hours a day just coming to Brisbane and back to go to work, so commuting is fairly high for me. But 4 hours a day is still much less than what I spend in buildings. So at this stage, what we haven't done is looked for any quantitative data regarding the indoor air quality of transport environments. So if anybody knows of any reports that we should include in that, please let us know. What we're envisaging at this stage is that next year's report likely won't include transport, but it should be included in a reiterative report sometime down the track. So if we're looking at buildings then, I wanted to get an understanding of how can we best structure the report so that it makes use of existing structures. So one of my areas of research is the National Construction Code. So the National Construction Code puts buildings into 9 different classes depending on what their general use is. So there's residential buildings, so I've put them together here, class 1 and 2. So this is your detached houses, townhouses, apartments, etc. And there are over 11 million residential class 1 and 2 buildings in Australia. The other buildings, so class 3 and 4A buildings, are other types of residential buildings. So this could be a residential parts of hotels and motels, detention centres, dormitories in boarding schools, hostels, large boarding houses, etc. There are approximately 88,500 of those types of dwellings in Australia. You can see the same for offices, so that's class 5, retail and wholesale buildings, so this is all your shops, restaurants, cafes, hairdressers, laundry, service stations, car parks, warehouses, storage buildings, etc. Then there's class 8, which are factories, so this is agricultural and industrial buildings that produce or assemble or repair or pack goods or produce, for example. Then under class 9 in the National Construction Code, there are 3 subcategories. So hospitals and healthcare buildings, public assembly buildings, and you can see the different types of ones there, so education, religion, cultural, entertainment venues, transport buildings, etc., and residential care buildings. So this might be aged care nursing homes, or it might be residential care for other people with disabilities, for example. So a couple of things of import. So the National Construction Code has this classification because different types of buildings have different requirements regarding how they're to be constructed and a lot of things that have to be in those buildings depending on what they're being used for and who is using those buildings. It's also perhaps interesting to note that the National Construction Code differentiates between detached houses or semi-attached houses and apartments. That apartments under the regulations are considered much more like commercial buildings than residential buildings because they tend to be a bigger scope. You have a range of families living in them, you have shared facilities and some common services, etc. So under the Construction Code regulations, high-rise apartments, for example, are treated differently to detached houses. All of this background might be boring to you, but if we want to make indoor air quality solutions, we have to understand the framework under which indoor environments are already regulated. So that's the main reason. The importance of what we feel why we would structure a report along this way is that each of these different building categories have different risks different pollutant risks, different time exposures, different populations and population densities and different demographics. And if we put a report in this structure, it may be more useful to the regulators and the industry who are already familiar with how to deal with the National Construction Code. So rather than trying to think of new regulations, let's try to present things in a manner in which industry and some areas of government are already familiar. Does anybody have any thoughts about, so I've tried to organise the intent is we present the scientific evidence in a manner that's familiar to the policymakers and to the industry who are all involved in the design, construction, refurbishment, etc. and operation of buildings. Does anybody have any thoughts about that?
Just on the operation of buildings, the NCC doesn't really cover that. You know, it's a builder's sort of spec.
Okay, I'll address that in a moment. So the comment for those who mightn't have heard is that the NCC covers the building, the design and construction, not necessarily the operation of buildings. I have perhaps a provocative view on that I'll mention in a moment. So, yes.
So mine. So we.
Yes. I'll touch all of it.
You're absolutely right to group residential class 1 and 2 together. But of course, class 1 buildings are in volume 2
Yes.
of the NCC, whereas class 2 buildings are in volume 1.
Yes, so,
It's difficult to treat them as a single group because they have such different regulations.
yeah, so the solutions for class 1 and class 2 buildings might be different because one you're talking about low-rise and single dwellings compared to high-rise buildings that are more commercial-like. The reason why in this report we're proposing to put them together is that they're occupied by families as opposed to being subject to workplace health and safety regulations. So it's more from an occupancy point of view, putting the class 1 and 2 together, but from a solutions point of view, it might be different. We might decide to split those depending on what the quantitative data finds.
Yeah, you're absolutely right that they're treated very differently under the NCC.
Yes, yes, they are. I agree. So let's talk about. Rafa, will take that.
Good.
So let's talk about the National Construction Code. That the protection of health is already a goal of the National Construction Code. That the goal of the code is to achieve nationally consistent minimum necessary standards to protect safety, health, amenity, etc. So health is already within the building codes. To get something in the building codes, it's required that any regulation that's in it is to be effective and proportional to the issues being addressed. In that sense, it has to show that there's net societal benefit and that the issue that's trying to be addressed is best addressed through the building codes as opposed to some other instrument. So, for example, in energy efficiency, they might decide that minimum energy performance standards of appliances is the best way to handle some efficiency things as opposed to in the building codes. So each state and territory government and the federal government have processes in place whereby if a change to a regulation is required, they have to do a regulatory impact assessment. In essence, they have to do a benefit cost analysis of what will it cost if we change the regulation, what will the benefits be, what if we don't change the regulation and keep it the same, what will the costs and benefits be? And we'll get more into that in a moment. Compliance with the National Construction Code is achieved by satisfying performance requirements. So in the code, there are certain things called performance requirements that you have to meet in the design and construction of your building. So is indoor air quality regulated in buildings? I believe that it is. In the National Construction Code, one of the performance requirements is this, occupied spaces must be ventilated with outside air to maintain adequate air quality. The second performance requirement is that mechanical systems have to be able to control the circulation of the odours, harmful contamination, microorganisms, pathogens and toxins. These are must-have requirements within the building code. The third is that any contaminated air must be disposed of so it doesn't create a nuisance to other buildings. This was an interesting one to me. I did a 6-month fellowship in London where we had the outlet from the gas appliances of the neighbouring unit was right next door to the fresh air intake for our unit, for example. So it was some of those things. So they are 3 examples of performance requirements that are mandated already in the National Construction Code that deal with indoor air quality. In addition to that, the Australian Building Codes Board, the board that manages the regulations, published an air quality verification methods handbook that actually specifies the maximum air contaminant limits of 8 indoor air contaminants. In addition to that, in the code, smoke alarms and or smoke detectors are required for all buildings. So in Class 1 buildings, they must all have a smoke alarm, and in Class 2 to 9 buildings, they must all have smoke detectors and smoke alarms. So we already have mandatory indoor air quality sensors in every building in Australia and in multiple rooms in every building in Australia. So I've heard some people say, well, you can't tell people what to do in their individual homes, we can't tell them to have sensors. Well, that's nonsense. From the perspective of we already do that for fire, why not do that for air? It does raise a question though, it's similar to the what's reasonably practicable, which we'll address in a moment, but what is adequate air quality? And maybe that can be interpreted different ways by different people, depending on whether you're a scientist or whether you suffer from an illness that's particularly triggered by air quality. But I would argue that because the Building Codes Board have produced a handbook that sets limits to 8 pollutants, they are already saying that this is the minimum level required, and it would be interesting from a legal case perspective on whether that would be considered, whether compliance with those requirements would be considered adequate air quality. The question is, and it relates back to your question before, or the question before about it's for design and construction of buildings, not operation, that are the performance requirements enforced only at design and completion? Because in essence, a building has to be able to show that it meets these requirements before a building is allowed to be occupied. But does that go into the operational phases? So just a hands up, who thinks that it's just at the design and construction phase? Who thinks it is at the operational phase? And who doesn't know? Okay, that's really, really interesting. In this building here today, do you expect that the evacuation, that if there was a fire, that there would be a fire alarm? Put your hand up if you expect that there would be a fire alarm if the fire went off. Okay. Put your hand up if you expect that if we have to evacuate this building and we can't use the lifts, you expect that we can all get to the evacuation door and walk down the 10 flights of stairs to an evacuation point. Do you expect that to happen? Do you expect that the structural integrity of this building will be sufficient that it won't collapse before we leave today? So you're expecting all those things which are in the National Construction Code for the design and construction of buildings will continue for the life of that building. Why should air quality be any different?
It references Australian standards on the main one, 1668 R2, explicitly says it's not an operational standard, it's a design standard.
The Australian Standard might say that, but the National Construction Code doesn't. And if you read the very beginning of the code, it says that the intent of the code is to drive the design, construction and operation of buildings throughout their lifetime. Yeah, because
It says a lot of things in the NCC, but it doesn't really mean them. So to have enforcement, you've got to have people to enforce the code. And of course, there aren't enforcers. The code is operated in each state by state legislation. It's not a federal act, and the ABCD is not a statutory authority. It's just a product of a memorandum between 6 states and 2 territories and the federal government. All of them have to agree on implementing any changes to it. So if any one of them holds out, nothing happens. So in the case that you raised about fire, there are provisions within all of the states' legislation. It used to be the NCC, but it was taken out and given back to the states to make sure that what's called essential services are maintained for the life of a building. But there are no provisions to do that for ventilation systems under Section F of the NCC.
so that perhaps presents an opportunity.
Well, it does, and it doesn't. So yes and no. I think the key there is this: the NCC. You're completely correct in the quote you've drawn from the NCC. But one of the things you'll notice about the ventilation handbook is it says that there's no test for pathogens. So it's never enforced because there's no test. So that, of course, and the other point I would just make very quickly, because I'm sorry to interrupt you, but this applies to buildings which are new. It doesn't apply to existing buildings. So there's a lot of existing buildings that, in fact, most buildings, as soon as they're built, start to go out of compliance with the NCC. And if we're going to solve problems with things like ventilation, we have to figure out what we're going to do about the stock of existing buildings.
Yep. Rafat, can you take the microphone to Kinnaman at the back?
Sorry, thanks for the presentation. It's been fascinating so far. Nick Bird from Facility Management Association, so really interested in how this all plays out in the operational phase. I didn't get to put my hand up with your last question because I think that there's flaws in every aspect of where it has requirements, and on occasion it doesn't meet any of the requirements, doesn't meet performance standards at any of those points in the life cycle of the building. So yeah, I think it's complex and difficult, and enforcement and governance around it, if that was got right, we'd probably see a increase immediately in the outcome of our built environment. So
yeah, I agree, and I'm not saying that the NCC is perfect in any way. We have similar issues of enforcing some things and not enforcing some things when we look at energy efficiency. So, for example, when my husband and I built a new house 15 years ago, in order to be able to get the certificate to be able to move into the house, the building inspector, for want of a better word, would come around and it would measure the height of the balcony rail to make sure that it was exactly 1 metre high so that kids couldn't fall off the edge. Or they'll measure the opening of the windows to make sure that a baby's head can't get out, sort of thing. But at no point did they come in and see whether the wall insulation or the roof insulation or the subfloor insulation was done according to the standards. So we already have in the construction code, we enforce compliance in some things, don't enforce compliance in others. But in a general perspective, we already have a structure that says buildings should meet certain performance requirements. And that includes air quality and includes energy efficiency. And now the latest version of the code also includes some renewable energy and battery storage and EV charging as well. So we already have some sort of framework in place, but we don't have a robust compliance framework. But what can we learn from that framework that might help us move forward? towards that, I guess is the point.
Sorry, can I just jump in with a question about another set of standards, which are the premises standards, which also apply to all public spaces. They set the standards for accessibility in terms of accessible entrances and ramps. They set the standards for assistive audiology. They set the standards for high touch, tactile surfaces. And they should also include indoor air quality as an accessibility feature to ensure that people living with chronic health conditions can breathe safely in all indoor public spaces. So I think that might be an interesting set of standards to also consider alongside the other ones that you're looking at.
Yes, I agree. I'll just look on the other legislation, and part of this was discussed this morning as well about is indoor air quality regulated. So WorkSafe Australia was mentioned this morning as well. So a little bit similar to the National Construction Code, the federal government doesn't provide the legislation on workplace things. They provide a model code and the states can decide whether to adopt it or not or modify it. But there are certain things within that code. I'm just going to move off the chat for a bit so we can see the slides. So first of all, and as Liam mentioned this morning, is that if you are a person that conducts a business or an undertaking, you have a legal requirement to manage the work health and safety risks from air pollution at the workplace. Let's see if I get this done. You are required, and here's the word again, as far as reasonably practicable, to provide and maintain a work environment that is without risks to health and safety. And they have some sentences relating to how a business might do that, and that's a risk management approach to identify the hazards, when they may be present, and the level of risk that it might pose, so then you can, as a workplace owner, you can then put in some ways of managing that risk. So it's a risk management approach. So this morning we had a bit of a discussion of what does as far as reasonably practicable mean. And as I tried to intimate this morning, that really depends on whose perspective you're taking. That if I was a building owner and it would cost me some money, I would say anything that costs me money is not practicable. I would argue perhaps that also what's reasonably practicable, which also means economically viable, changes from year to year depending on what technologies are available. So I would argue that for workplaces now, because of the rise of low-cost sensors, because of the Internet of Things and because of AI, it is probably reasonably practicable for most workplaces to be able to put some air monitors, sensors and monitors in nearly every workspace now in an economically viable way. That's still to be determined whether that's possible or not, but that's one of my suggestions. And as Liam also mentioned this morning, that even though the WorkSafe guidelines are for the protection of workers, they're really to protect all people who go to a workplace. So that means everybody who goes into a shopping centre, into a cinema complex, into an indoor pool, into a gym, for example, that the owner of that business is required to protect the air quality for everybody who goes into that house. Just as an aside, one of the retail businesses that concerns me about air quality is hairdressers and nail salons. So who's been to a shopping centre and you walk past a nail salon or something and you get this wall of VOCs, presumably, coming at you, but there doesn't seem to be anything within those businesses and within the shopping centre as a whole to try to manage those things. And we'll see that in a moment. So because we had a bit of a discussion on what's reasonably practicable earlier today, I'm going to move on from that now and suggest that Liam suggested this morning that we might have a tiered response to indoor air quality. I'm suggesting that the National Construction Code on how they handle fire also presents a mechanism that we might like to think about. So when you look through the codes relating to fire, there's 4 stages of addressing the risk that fire and smoke poses to occupants of buildings. The first is the source control, which looks at the flammability of the materials that a building is made out of. And different structures within a building are assigned a fire rating level, which indicates how long will that, if that structure is exposed to fire, how long will it take before that structure fails and the fire spreads to something else. So the fire rating level, if this was an apartment and where we had our morning tea was the next apartment, the fire rating level of the wall in between has to be a certain level, which will be different than if it was one classroom to another or from one office building to another. So the source control of the fire is the first step. Then there's the spread control. So there are lots of regulations regarding how do we make sure as the fire starts in a building, it is isolated just to the part where it starts, and that the smoke from that fire is also managed so it doesn't seep under the doors, go up the stairwell, and the smoke, as opposed to the fire, doesn't impact on other people. Then there are monitoring and alarms about the fire. So there has to be monitors and alarms that tell people, that the occupants of the building, that there is a problem, and there has to be a manner in which those people can be safely evacuated from the building. And that's everything from how wide the corridors have to be, how wide your evacuation doors have to be, how many levels of stairs do people have to go down in order to be evacuated, how many evacuation doors are needed. And then there's the suppression parts of the fire risk approach. There's requirements for how long hose reels have to be, how many fire retardant devices have to be around in certain particular places, how many sprinklers, etc. And for some buildings, an automatic response to the fire brigade. So that risk approach to fire could be applied, for example, to indoor air quality. But the two main things from that risk approach is that occupant safety is the first priority of the approach to fire. It is not to protect the building.
Yeah.
The things in the code are to protect the safety of occupants. And secondly, that there are different solutions to the fire management for different buildings depending on the context, the type of the building, how many floors the building is, how far you are from a fire brigade. Can the fire brigade hoses reach beyond 11 stories or so? The size of the building, the number and type of occupants, etc. So already there's a framework within the codes that provides a fairly good framework that we might like to apply regarding codes. So then the next step in terms of doing this report is looking at, well, what contaminants do we think this report should quantify to start with? So we looked at the blueprint for air quality standards that Lydia mentioned before. We looked at what pollutants are already mentioned in the National Construction Code, and we looked at the WHO 2021 guidelines. And this is a list of 8 pollutants, or 9 if you count the PM 2.5 and 10, 2 different ones. This is not to say that these are the only pollutants that should be measured or monitored in the building, but to start off this report, we needed a list to be able to do a literature search to see what's been quantified anyway. And coming up to that is also looking at what level of pollutants or exposure limits do we consider to be appropriate. So I found it really interesting doing this table, which compares the standards that the blueprint is suggesting with the WHO guidelines, the NCC guidelines, and WorkSafe Australia guidelines. I'd like to draw your attention to the first 3 rows in particular, to just see how divergent they are. So WorkSafe Australia propose in their standards a time-weighted average of 5,000 ppm over 8 hours for carbon dioxide. The NCC says 850 for a short-term exposure limit. Lydia's blueprints are talking about an absolute limit of 800. There's a fair bit of difference. Okay, perhaps CO2. So let's look at carbon monoxide. So WorkSafe Australia says 30 ppm. The WHO 10 milligrams per cubic metre. I'll take questions in a minute on that part. So just one thing that we should perhaps be aiming on doing sometime the next year or so is looking at the different exposure limits and the difference between time-weighted averages and absolute exposure limits as well, and what is it that we're trying to do and what's feasible. So the question that I wanted a little bit of feedback on are those 8 pollutants acceptable for the initial literature reviews? And should we be including dust, mould, pathogens, ultrafine particles in this round, or do we wait till next round? And part of that will depend on the person power that we have and whether anything has actually been published that quantifies any of those things. So, do you want to have a comment about that?
I'm not answering your questions, I'm afraid. I wanted to just ask when the WorkSafe Australia regulations or metrics were last updated. Is that from quite some time ago, or are those being reviewed? Every few years or so?
I can't remember the exact date on that. I think they're relatively old, but I think an update is due in 2026. But I couldn't find what they were updating to and what specific exposure. So.
And in relation to your questions, of course, I would defer to the eminent experts in the room, but I am interested in the views.
Can you just speak up a little bit?
I'm interested in the views of the experts in the room on the ultrafine particles and whether we should be looking at that.
Lydia, do you want to address that?
Yeah.
Yes, we actually already had a conversation about this to include this, and one reason for this that there is a large body of evidence which we've generated here, because this has been the focus of our work, so we know a lot about this on the one hand, and on the other hand. In 2021 edition of the WHO guidelines, there is a section on ultrafine particles good practice. There are no numerical guidelines because there's not exposure response relationship curves available yet. However, there are typical values which we can refer to. So I guess that's what we plan to or hope to include as well.
So I think, if I can just hold questions for a moment, I think at this point, because of the personnel that we can commit to doing the report, that we have actually started with this list first, with all the published data on this, and we'll see what additional time is left to be able to add these other things or to search the literature about quantifying these other things. So if you hold your questions for a moment, I just wanted to show you then what have we found to date, and keep in mind that when you had the table before about the building classes, that we have over 12 million buildings in Australia that we're trying to monitor the air quality for. So what we've done to date is we've started a systematic literature review with some new members to the Thrive team. So we've been looking, so remember that the purpose of this report is to provide quantified data about the state of indoor air in Australian buildings. So we've looked at peer-reviewed journal articles published since 2000. So we had to have a year to cover. That's already, a quarter of a century old. We will probably extend that down to 1990 or so. We're looking at papers that have had actual indoor air measurements in Australian buildings as opposed to simulations or qualitative data. And at this moment, we've only looked at those 8 pollutants we mentioned before. So just quickly going through them. So for residential buildings in class 1 and 2, we found 38 publications, and they cover 1,284 dwellings, remembering that we have over 11 million of them. So we don't know very much about what's going on in people's homes. And those papers cover 5 capital cities, and they measure, and different reports measure different pollutants. For the other residential buildings, The only paper we found to date is a prison, and we don't know where that prison was other than it was in a regional area, which means that there is no data about the indoor air quality of hotels and motels, of dormitories at boarding schools, etc., etc. And maybe that's part of the problem during the COVID thing when we thought, well, let's just put everybody in hotels to keep them safe. When we don't really know what the air quality in a hotel is and how their ventilation systems work anyway. For offices, only 9 articles, and there's, I think, something like 250,000 office buildings in Australia. So it covers 55 buildings in those capital cities. And on the right-hand side, you'll see there about the pollutants that have been recorded, some of the minimum and maximum ranges. We also intend, though, to analyse the indoor environment quality data from NABERS. So NABERS is the National Australian Built Environment Rating Scheme. So they have ratings for water and energy in buildings, for indoor environment quality, also now for embodied energy. So we will be looking at their data sets to see, for their office buildings over the last 10 years, what types of ranges of indoor air quality have been reported. But it's still only a really tiny proportion of the buildings that have been done. For retail and wholesale buildings, it's also a poor example of what do we know. We found one publication about some cafes and restaurants and clubs in Perth, another about another building in Perth. But in essence, we don't know anything about shopping centres, about individual types of shops. For example, like hairdressers and nail salons that actually have a high chemical load to start with. For industrial buildings or factories, etc., only one paper was found, and that was a brewery. So we don't know about the air quality about a lot of our industrial buildings. But presumably, because a lot of them deal with chemicals, they're being covered by WorkSafe Australia. Health buildings as well, not much on the terms of hospitals for those 8 pollutants that we have searched for to date. Public assembly buildings are also interesting. There are more reports on education buildings than there are on sports centres or clubs. There are no reports on nightclubs, on religious buildings, so the churches, mosques, etc. And not many reports on residential aged care for those 8 pollutants that we looked at. So of the 12 million buildings that we have, we probably have data ranging from the last 10 years or so on maybe 0.01%. So what's next is the role of partners if you wish to be involved in the development of this report. One thing we're really interested in finding is if you have data to contribute, so measured, quantified, scientific data about indoor air things that may not have been published in the peer review thing that will be interesting, and a range of things. So come and speak to myself or Rafat or Lydia later.